Hello everyone, I am Dattatranikam. Welcome you all on channel eFunda. New day, new topic. And our today's topic is understanding of process flow diagram, that is PFD, and a piping and instrumentation diagram, that is P&IDs. And if you are new to our channel, then please visit to our channel eFunda and watch all the videos created related to various topics of engineering, fundamental, project and career, telecommunication engineering, procurement engineering, instrumentation and control engineering, deliverables, and many more. And don't forget to subscribe to our channel to get latest notification on upload of our new video on our channel eFunda. So let's begin with our today's topic, that is understanding of process flow diagram and a piping instrumentation diagram. Now starting with understanding of PFD and P&IDs, the most important document of a basic engineering are the piping and instrumentation diagram, that is the P&IDs, process engineering, international standard, work standard, request from production, startup and shutdown, unusual operating situation, safety aspect, process control, service friendliness, pipeline classes, instrument cost, and many other items must be taken into account while preparing or preparation of the P&ID. Now we will see the figure where we will cover the root of P&IDs. One can refer to the block diagram where BFD, that is a block flow diagram, then passing it to the PFDs, and then finally reaching it to the P&IDs. As part of the basic engineering packages, which contains the following information as a minimum: A, project design basis and a process description or a block diagram; B, process flow diagram, that is a PFDs, mass and heat balance; D, utility list; E, piping and instrumentation diagram, that is a P&ID; F is the equipment specification; G is the process control description; H, instrument specification; I, preliminary equipment layout; J, preliminary operating instructions; K, guidelines for construction, operation and the maintenance; L, catalyst, chemical and effluent plant data; M, hazardous area classification. This is how the importance of the basic engineering where PFD and P&IDs are required. Now we will see more details about the PFDs. Block diagram and a process flow diagram, that is a PFD. Block diagram we will see. A block diagram, flow diagram, is used to show the major process equipment, interconnecting process flow lines and flow rate, stream composition, temperature and pressure when necessary is required for the clarity. The block diagram or block flow diagram is a simplified diagram. One can refer to the block diagram where one can see the hydrogen is an input to the hydrogenation section, and similarly the output goes to the oxidation section where process air is connected, and the further catalyst will be reconnected to the hydrogenation section. And similarly the concentration section, extraction sections are interconnected, and simultaneously the working solution return line is connected further to the hydrogenation section. And similarly the output for the concentration section, that is hydrogen peroxide 50% concentration. This is how the typically the plant requirement or the plant details were covered. Further, based on the block diagram, process flow diagram is developed, and our process flow diagram, the product flow diagram or PFD, is a representation of the order by which a sequence of the product is created according to the product based planning and the principle. PFDs mainly include process piping, major equipment symbol, name and identification number, control valves, valves that affect the operation of the system, interconnection with other system, major bypass and recirculation line, system ratings and operational values as a minimum, normal and max flow, temperature, pressure, compositions of the fluid. One can refer to the process flow diagram where the feed tank is shown, then the furnace and the column, and subsequently to the reactors, exchanger and product tank, etc. Similarly the cooling tower is also connected, and further the bottom tanks for the recirculation. This is how the typically the major equipments interconnecting lines are shown, so that one will get the feel about the number of equipment involved in the plant, and the flow lines are connected to respective equipment, and the process flow scheme is shown from the arrow mark to the respective equipment. The major control instruments are shown to help or clarify the mode of the operation, but the bulk of the instrumentation used for startup, shutdown, minor control is usually omitted from the PFDs. Now moving on to piping and instrumentation diagram, that is P&ID. Typically a piping and instrumentation diagram displays the piping component such as equipment, valves, reducer and so on. And when the actual physical process flow line and is often used in the engineering project such as setting up the steam boiler, heat exchanger, electric boiler and more. One can refer to the typical P&ID. We will see this is the extension of the PFD where more the details are covered. One can see the feed tank further to the connected to the furnace to the column, and column to the tank where the agitator is there. From there it is connected to the exchanger and further to the product tank. Similarly, upper side of the column drum is shown, and further it is through the vacuum pump, and similarly the cooling tower is also connected. So this is how the details are covered. One can see the respective instrument starting from the feed tank where we have the flow transmitter connected to the FCVs for the regulation at the furnace level, and then the temperature is being measured at the furnace level so as to control the discharge from the furnace through the control valve, and similarly the outlet is coming from furnace and connected to the column where the level is also shown, and from the bottom of the column the discharge line that is connected to the back to the bottom tank is also controlled through the level instrument, and simultaneously the other side it is going to the pump section where the exchanging level is being measured through the temperature and respective TCVs are being controlled. This is how the typically all the instruments are required to have the accurate control of the entire plant is shown on the P&IDs. This is how the typically it covered. Through P&IDs you can get the following information: A, the mechanical and electrical detail of a given system or a process; B, piping information such as sizes and the material specification; C, continuation flag leading to the connecting P&IDs; D, flow arrow DCS alarm types; E, the connection types from the controller to the field devices. This is how the P&ID gives the information with the required details of the instrumentation and connecting flow lines. Now we are moving on to how to read and understand the P&IDs. We have already seen what is a block diagram, PFD and P&IDs. Now we will see the more details about reading of the P&ID. The P&IDs gives a graphical representation of the interconnection between the piping and instrument. More specifically, P&IDs are defined as a graphical representation of the piping, including the physical sequence of the branches, reducer, valves, equipment and instrumentation and control interlocks. The details of the instrumentation varies with the degree of the design complexity. In this related, we have already created the videos where we have covered the ISA standard, codes, regulation, etc. and the details of the combination which are being used for the P&IDs. We will see some of the steps. First step, to know the letter and number of combinations of a P&ID. A letter and a number combinations appear inside each graphical element, and letter combinations are defined by ISA standard. Numbers are being used or user assigned. The first letter defines the measure or initiating variables. One can refer to the instrument symbol tag identification. One can correlate this. A is the analysis, flow is the F, temperature is the T, etc. with a succeeding letter defining readout, passive or output functions such as indicator as I, record as R, transmit is the T, and so on. Similarly, the tag number, a tag is a logical name for a variable in a devices or a specific item. The instrumentation tag gives the identification for a particular item, example 202 FT 1001. For understanding this, one can refer to the pictures where the circles are denoted with a letter in the middle are indicating the functionality, that is the temperature indicator, TT is the temperature transmitter, flow indicator, flow transmitter, PIC, that is the pressure indicating controller, pressure controller, etc. The first letter indicates the parameter being controlled, monitored or measured. The second letter tells you about the device type being used. Letter third, fourth and fifth further designates the function of the component and modify the meaning of the preceding letter. This is how the step 1 covers. Step 2, identify and understand standard equipment, that is instrument. It is also important to know how to read its symbol and shapes into the drawing. Instrumentation symbol in P&IDs are standardized as per ANSI ISA 5.1 standard. One can refer to the picture on the right hand side where TIC01 is indicated as a one function, and their details of the each letter and their symbol, location, identifying number, instrument symbols are covered. Then this standard ensure a consistent and a system independent means of communicating instrumentation control and automation intent by providing standardized instrumentation symbol and identification so everyone understand. Now instrument location, one can refer to the first picture where only the circle is indicated, that means no line. A simple circle indicates that the device is in the field and is locally mounted instrument, that is the device is observable in the field and is accessed by the operator. Solid line, a second picture, a solid line in the center signifies that the instrument is placed in a primary location in the control room where the instrument is visible on the front of the panel or the video display unit. A dashed line, the third picture, the dashed line specifies that instrument is in the secondary position in the control room and is not accessible by the operator. This means the instrument is not visible on the front panel or the video display. Double solid line, that is a fourth picture. A double solid line tells you that it is a primary position in the local control center and is operator accessible at the panel front or the console. The double dashed line, one can refer to the fifth picture where a double dashed line describes that the instrument is in the secondary position into the local control panel and is not accessible to the operator. The device is located in the field cabinet and is not visible on the front of the panel or the video display unit to the operator. Next point is shared display and shared control. Shared display means when the same information can be viewed and accessed from the different location in a network. Shared control indicates that the user can interact with the system and modify the operational conditional remotely. For representing an instrument with a shared control and display system, take the tag number and draw a square around it. This indicates that now instrument can be accessed remotely or into a distributed control system, for example that is the DCS. According to ISA S5.1, there are mainly 4 graphical elements, that is a discrete instrument, shared control display, computer function and programmable logic controller. One can see the symbols on the right hand side where LIC001 is shown, which is a physical instrument, and similarly part of a shared display and shared control in a DCS, that is a LIC001 is shown with a square around the circle. Similarly, one can refer to the symbols where the discrete instrument is shown, where one can see the circle with a single line and only the circle with a 2 lines. Similarly, the shared or the control display on the second picture. Third is the computer function And last one is the programmable logic controller, where instead of the circle, two squares are being used so as to indicate that this is the ESD or the PLC programming control action is being used into the plant, so as to differentiate between the DCS and ESD system. These two different symbols are being used in the P&IDs. Step 3, learn to use graphical element and connecting lights. The connection lines on the P&ID elaborate about the associations between the instrument, how they are connected to each other, and the type of signal being transmitted. One can refer to the table where all the symbols for the specific purpose are indicated: major process piping, minor process piping, electrical signal, that is a dotted line, mechanical link through connecting lines, electromagnetic, that is a guided wave, one typical line, electromagnetic unguided wave with unguided without line, pneumatic signal is shown with two dash crossed across the line, software or the data link, that is a serial link with two soft circles are connected with one line, capillary tubing, two cross with one typical line, hydraulic tubing, that is shown with a symbol L. For example, a solid line signifies the connection is via pipe, while a dashed line indicates with the electrical transmission line, which we have seen just now. Now we have reached to the section where we will see the final product P&ID. One can refer to the P&IDs shown, where all the interconnecting piping to the respective equipments, and further these lines are connected with the instruments, where the various levels of instrumentation applications are being done, that is a level control, actuation of the control valve, measuring of the pressure and controlling the pressure with respect to the line pressure of the compressor sections, and if any additional things are there in the line, then it will be vented out to the flare or the safe location through PSV. One can see the typically P&IDs, how the details are being captured can be studied by understanding the P&ID, and for more detail one can refer to their project specific P&ID, and this video will help you to understand by following the steps which we have covered in today's video. With this, we are concluding on our today's topic, and you can find our channel details as follows. If you are new to our channel, that is our YouTube channel eFunda, then subscribe to our channel eFunda, and don't forget to press bell icon to get latest notification of upload of our new video on our channel eFunda. Similarly, you can follow us on a Instagram page. Similarly, you can follow us on our Facebook page as well. And keep watching our channel eFunda for various topics related to engineering and a project. With this, we can assure you this will help you to better your understanding on engineering and a project topic. Keep watching our channel eFunda. Thanks. Watch our channel for new day, new topic.